maximize light and blur that line. For me, okay, let's unpack this. When you look at, high-end contemporary architecture,
Yeah.
what's the first thing that really grabs you? For me, it's always the glass, these huge, just seemingly unsupported walls of glass that are designed to maximize light and blur that line between the inside and the out. We're talking about getting that perfect uninterrupted view, right? Where a home just opens completely to its environment. But that feeling, that sense of effortless luxury, is ironically the result of some incredibly heavy-duty engineering.
That's absolutely right. The aesthetic of minimalism is really built on a foundation of, well, maximal strength. Our deep dive today is focused entirely on those hidden mechanics. We're getting into the technical specs of insulated aluminum sliding door systems, specifically looking at the SF60 and the ultra-high performance SF80 models. And the mission is pretty simple. We want to see exactly what design details, what engineering certifications are needed to deliver a luxury glass wall that can also handle a hurricane.
And when we say handle massive glass, we should probably start with the sheer structural capacity. These systems, both the SF60 and the SF80, they're insulated aluminum systems. They're designed to be flexible, so sliding left or right, 2-track or 3-track configurations. But here's the detail, the technical detail that really sets the stage. It's the maximum casement weight these profiles can support.
Right, and casement weight, just for clarity, that's the weight of the moving panel itself, with the glass in it. And that figure, it's the thing that underpins the entire structural capability of these doors. It's a staggering 800 kilograms.
800 kilograms. That's the weight of a smart car.
Uh-huh.
Or like 5 average refrigerators, all just hanging in one frame, ready to be rolled open. That one number tells you everything you need to know about the scale of the glass panels we're actually talking about.
Precisely. That 800 kilogram capacity is the foundational requirement. It's what allows architects to specify these incredibly large single panes, and it lets them use the wide range of glazing thickness these systems can take, so anything from a slender 32 millimeters up to a really robust 54 millimeters.
Mm-hmm.
That depth is what allows for the heavy, multi-layered glazing that's just essential for thermal and acoustic insulation in these kinds of high-end projects.
But here's the paradox, right? Something that heavy shouldn't feel heavy. You don't want to have to muscle an 800 kilogram door open every morning. So how was that massive load translated into what feels like an effortless glide?
Well, that magic happens in the mechanics, really, right underneath the glass. The smooth operation relies entirely on these high-precision, ball-bearing stainless steel rollers, and they run on matching stainless steel rails. These components are designed not just for the load-bearing, but for distributing that weight evenly and really minimizing friction. It's the difference between dragging something massive and letting it float on, well, industrial-grade bearings.
Which sounds like a system designed for minimal maintenance over the long term. And that's exactly what a client at this level would expect.
It is. Now, beyond just the daily operational load, we have to think about environmental stress, especially on huge spans of glass. So a critical structural detail in both systems is the option to incorporate steel reinforcement right in the middle joint of the frame. This is crucial for resilience. If you have an enormous panel in a high exposure area, say, I don't know, the 20th floor of a skyscraper or a home facing the ocean, you need that integrated steel to resist massive structural deflection under intense wind pressure.
So once we've established that you have the sheer strength to hold this massive piece of glass, the next question is, can it actually seal against the elements? Here's where we move from brute strength to precision performance. What do the standardized ratings actually tell us about how these systems perform when the weather turns nasty?
Right, so we shift our focus to the performance metrics. We can start with thermal efficiency, which is usually measured by the U value. This value basically tells you how well the entire assembly, so the frame and the glass, resists heat transfer. For both the SF60 and SF80, the thermal performance starts at an exceptional zero point 0.8 watts per square meter Kelvin.
Wow.
Though, the final number will always vary a bit based on the specific glass and the overall size of the door.
And just to put that into perspective for you, achieving a zero point 0.8 U value is a tremendous feat for a massive operable glass wall. It means the system's performing almost as well as a standard insulated wall. It minimizes your heating and cooling loss, which is, frankly, remarkable given the surface area of glass we're talking about.
Absolutely. So now let's dive into the specific DIN certifications, because these are the verifiable proof of that performance. We need to look at 3 key categories that define weather resistance, and we can start with air permeability.
Okay, so how tight is the seal?
Exceptionally tight. Both the SF60 and the SF80 are certified to Class 4 for air permeability. And you don't need the whole technical code number, just know that Class 4 is the highest class for air tightness. It means the infiltration of external air is virtually non-existent.
Which is key.
It's key for maintaining your interior climate and managing humidity.
Okay, moving on to the sheer physical pressure these doors can withstand, the wind load certification. This is where we start to see the two systems diverge a little bit, right?
This is the critical trade-off point, yes. The SF60 is certified Class C3B5. That's robust, it's great for most residential and standard commercial applications, but the SF80, that achieves the significantly higher certification of Class C5.
C5. So what does that really mean in practice?
Class C5 specifically indicates superior resistance to deflection under extreme sustained pressure.
So if I'm an architect and I'm designing a penthouse on the 40th floor, or maybe a beachfront property that's directly facing a gale-prone coast, the SF80 C5 rating is what I'm paying for. That higher classification means the glass isn't going to flex inward under, hurricane-level winds.
Precisely. It maintains its structural geometry and its integrity. It ensures the frame doesn't deform and then compromise the seal. And that structural integrity ties directly into our final metric, driving rain resistance.
The ultimate test, right? Keeping the interior dry when the wind is actively trying to push water through the seal.
And this is maybe the most pronounced difference in performance between the two. The SF60 achieves Class 9A, which is excellent, but the SF80 is certified to the advanced standard of Class E750.
E750. Okay, that sounds like a number from a science textbook. Can you ground that for us?
Think of it this way. 750 pascals is the force exerted by sustained winds well into the severe gale force range, just actively pushing a sheet of water against the door. So this certification proves that the SF80's drainage and sealing channels are engineered to handle the most severe wind-driven rain scenarios without failure. It's a non-negotiable for true high-exposure building sites.
It's amazing that this level of strength and weather protection is packaged into a system that is, by design, meant to virtually disappear.
Right.
So let's focus on those aesthetic details that ensure maximum transparency.
Right, because the primary architectural goal is to shrink the visual mass of the frame down to the absolute minimum.
And the numbers really bear this out. The overall outer frame is 60 millimeters, but it's specifically designed to be, and I'm quoting here, completely coverable by the surrounding wall, so it just vanishes. The actual panel frame is 45 millimeters deep, yet only 21 millimeters of that is visible when the door is closed.
And that minimal look is perfectly realized at the center joint, where two of those massive 800-kilogram panels meet. The vertical line that breaks up the view is only 30 millimeters wide.
Just 30 millimeters.
That narrow sight line creates a virtually seamless visual break. It transforms what should be a heavy structural element into this fine, almost pencil-thin line that's architectural finesse.
The source material also mentions another key detail for installation: glazing beads for easy alignment. What exactly are those doing?
Glazing beads are, they're essentially the removable internal strips that hold that heavy glass pane securely inside the frame. Since these glass panels are so thick and heavy, up to 54 millimeters, the beads make the installation process far simpler. They let you place the glass, align it, and then securely fasten it without a ton of stress or complexity for the installers. They ensure precision.
Okay, let's talk security. You have an 800-kilogram piece of glass on high-end rollers.
Yeah.
What kind of locking mechanism keeps that massive assembly safe and sealed?
Security is paramount, of course. The engineering of the lock has to match the integrity of the frame. The core locking mechanism uses a specific component called a mushroom headlock.
A mushroom headlock. That sounds intriguing. Why that specific shape?
The term's purely descriptive. It refers to a locking pin with an enlarged, mushroom-shaped head. Unlike a standard flat bolt that just slides into a receiver, which can be pried out, the mushroom head actually keys into the frame profile. So when pressure is applied externally, like a burglar trying to pry the door open, that head cams against the frame, making it physically impossible to lever the lock out. It's designed for an optimal seal and improved burglary resistance.
And for someone seeking the highest level of protection, is there an upgrade path?
Absolutely. The system offers an optional security package that can get you up to resistance class RC2.
RC2.
That's a standardized European classification. It means the door has been independently tested to resist attack by tools like screwdrivers and wedges for a sustained period of time.
Even the handle is part of this aesthetic commitment. The material highlights the handle design as a handle with PZ. What does that PZ designation mean here?
Well, the PZ refers to the profile cylinder, the key mechanism, but the real takeaway here is the aesthetic. The handle itself has a flat cubic shape. It just shows the designer's focus on making sure even the necessary hardware maintains that minimal modern look. The hardware isn't allowed to interrupt the clean lines of that 21 mm frame.
And finally, let's look down at the foundation, which really sells the whole illusion of a seamless transition. Both systems feature a fully recessed floor track. The source notes a depth of 80 millimeters.
The recess track is what truly completes the aesthetic, delivering that unbroken floor look everyone wants.
Yeah.
When you look at the cross-section images, the visible part of the track, that slight rise above the finished floor, is minimal. It's only 21 or 31 millimeters above the profile base. And that low profile is crucial, not just for looks, but for practical accessibility. It makes the transition seamless.
So we have two phenomenal systems, the SF60 and the SF80. They both share that impressive 800-kilogram capacity, the RC2 security potential. But that extra performance we saw in the certifications, that Class C5 wind load and the E750 rain resistance, that has to come from a physical difference. We know the key differentiator is construction depth.
It is the defining variable. The SF60, for a two-track system, has a construction depth of 170 millimeters, and its three-track version is 260.
And the SF80, the champion of extreme performance, is visibly deeper. The two-track is at 210 millimeters, and the three-track expands to a pretty substantial 320 millimeters.
And if we look at the bigger picture, that extra 40 to 60 millimeters of profile depth in the SF80 isn't just wasted space, it's the literal engineering requirement for superior climate control. That depth provides the space for more insulation chambers, more robust connections, the ability to integrate heavier steel reinforcement. It allows the system to withstand that 750 pascal pressure and achieve the C5 wind load rating. The depth is the price of admission for that ultra-high performance certification.
So the final takeaway for you, the designer, or maybe the highly informed homeowner, is that the difference between a high-end system and an ultra-high performance system isn't really found in the glass itself. It's in a few critical millimeters of aluminum profile depth. And those extra millimeters deliver massive dividends in verifiable climate certification and, I suppose, peace of mind.
Exactly. We've seen that these doors are defined by their ability to seamlessly manage truly massive loads, up to 800 kilograms, while maintaining these extremely narrow face widths, sometimes as slim as a 30 millimeter center joint, and delivering exceptional thermal performance with a U value starting from 0.8. It's an amazing balance of strength and minimalist design.
This raises an important question, I think, for anyone designing with or purchasing these systems. Since these doors are engineered to handle the immense pressure loads of a hurricane, and they use sophisticated locking like the mushroom head design to get to an RC2 resistance class, you have to ask, at the absolute extreme edge of performance, which aspect of the door is the true limiting factor? Is it the massive, thick, insulating glass itself, or is it the sophisticated aluminum profile and the locking hardware? Which one is the real bottleneck in achieving maximum security and weatherproofing standards? It's something to ponder when you look at that seemingly effortless, seamless wall of glass.